Hi guys, my name is Ibraheem and I'm a student of the Mechanical Engineering Department at Bilkent University. Today we'll be performing our Physics 102 experiment, which will be determining the variation in voltage across a length of wire using a simple circuit. The main objective of our experiment is going to be to determine the drop in voltage across the length of a wire because of its internal resistance. To perform this experiment, I used a uniform copper wire, a DC power supply, two digital voltmeters, crocodile clips, 200 ohm resistors, and a slide wire potentiometer. The setup involved connecting the copper wire in series with resistors and a power supply. One crocodile clip was fixed at the start of the wire, while the second clip could slide along to different points. At each position, I measured the voltage at 2 points, V1 and V2. The theoretical foundation of this experiment is based on Ohm's law, which states V equals IR, voltage equals current times resistance. In a uniform wire, resistance increases linearly with length. According to the equation, R is equals to rho L over A, where rho is the resistivity of the wire, L is the length of the wire, and A is the cross-sectional area of the wire. Substituting this into Ohm's law shows that voltage should be directly proportional to the length of the wire, assuming constant current. Here's the table of data that I collected during the experiment. For each trial, I recorded the wire length in centimeters, the two voltages at different points V1 and V2, the voltage drop V2 minus V1, and the voltage drop per unit length V over Cm. At shorter wire lengths like 5 centimeters, the voltage drop was about 0.989 volts. As the wire length increased, the voltage drop generally decreased. For example, at 10 centimeters, the voltage drop was around 0.786 volts. At 15 centimeters, it was about 0.508 volts, and at 25 centimeters, it dropped to just 0.130 volts. Although the general trend matches the expectations, the voltage drop per centimeter isn't perfectly constant. This slight fluctuation could be due to the constant resistance at the clips or minor variations in the wire's materials. I then plotted the voltage drop against the wire length. The graph showed a clear straight line trend, confirming that voltage drop increases linearly with the wire length, just as the hypothesis predicted. From the graph, the slope P was calculated to be approximately 41.71 ohms per meter, representing the wire's resistance per unit length. The y-intercept Q was approximately negative 0.88 volt, indicating minor systematic errors like poor electrical contacts or internal resistance within the voltmeters. These results directly support my hypothesis. Since resistance is proportional to length and voltage is proportional to resistance, the voltage drop increases linearly with distance along the wire. Of course, there were some sources of error. The crocodile clip sometimes didn't make perfect contact with the wire, causing the voltmeter readings to fluctuate. The sliding motion disturbed connections, leading to inconsistent voltage drops. To improve accuracy, I recommend using a firmer metal slider instead of crocodile clips and ensuring all connections are tightly secured before each measurement. In conclusion, this experiment demonstrated that the voltage drop across a uniform wire is directly proportional to its length as predicted by Ohm's law. The data, graph, and analysis all confirm the hypothesis. This understanding is fundamental for designing safer, more efficient electrical systems in engineering. Thank you for watching.